Here are three communication questions from this section on vectors in R2 and R3. C1 is explain how will you show that the points A 2 minus 2 1, B 1 minus 3 minus 5 and C 3 minus 4 minus 4 are the vertices of right triangle. C2 is for what value of k is magnitude of k minus 2 times vector v equals to 4 times vector v, its magnitude, where vector v is not equal to 0. Let me write 0 vector here. C3, write a vector that is perpendicular to x-axis in R2. And then part B is plane xz in R3. So you need to write a vector that is perpendicular to these two things, right? So perpendicular to x-axis in R2 and perpendicular to plane xz in R3, correct? These are the questions. So read these questions properly and then answer them. Now, you can stop the video. Once you have answered, then look into my suggestions. C1, there are a couple of ways to show that these 3 points can form a right triangle. One way is Pythagorean theorem, right? So if we have a right triangle, let's say this is a triangle, and let us say this is a right triangle, right? In that case, we know square of these two sides, sum of square of these two sides should be equal to this side, correct? That is Pythagorean theorem. So I'm not writing which point is A, which is B, and which is C. That is for you to figure out. But let us say that one side is P, the other side is Q, and the third side is R. In that case, if you show that P square plus Q square equals to R square. So as you know, these vertices are A, B, and C. We can find the length AB, BC, and AC. And if we can prove this, then that means they form vertices of a right triangle. So that's one way of doing it. Second way is to find the angle between the two sides, right? You can always find these are the vectors. AB is one vector, AC is the other vector, BC is the third vector. Like that, there are 3 vectors, and you can just find out angles between the two sides, and from there also you will know whether it's right angle or not. At this stage, if you've done the dot product, then that is probably a good way of proving that the sides form a right triangle. If the dot product is 0, that means the two vectors are perpendicular. So these are the 3 ways when you can answer C1. C2. For C2, magnitude of this term should be 4 times V. That means k minus 2 should be 4, and so k should be 6, correct? So that gives you the answer for C2. C3. So visualize. It says write a vector that is perpendicular to x-axis in R2, right? So you know that vector is what? So if this is x-axis, the perpendicular vector is y-axis, correct? So that is the vector which is perpendicular to x-axis. Now the thing is how to write this vector. So at times students get confused about this. So you could write in unit vector notation, that is ijk using, right? So if this is x-axis and this is y, then this vector could be j, right? So if I write j, so this itself, let's say the vector a equals to j, it itself is perpendicular to x-axis. Or if you want to write in Cartesian coordinates, then 0 is the value for x and 1 is the value for y. So that is another way of writing a vector, which is in this case a unit vector along y, and that is of course perpendicular to x, correct? So that is how you can give you a vector. Part B is plane xz in R3. So it is not plane xz in R3. Many times I've seen students just writing equation of the plane xz in R3, right? Actually, strictly speaking, the question is perpendicular to, right? Don't forget that part. So that is kind of your 3D thing, right? So plane x and z is this plane. Write a vector that is perpendicular to this. This is the vector which is perpendicular to the plane xz. Do you see that? So you need to write again y-axis. That is what you need to write. Now this is y-axis here, this is x, and that is z for you. Now what is the equation of vector along a y-axis? So its position vector could be this, right? So we could write this as, so you don't move along x, but you could move one unit along y, and you don't go along z either. So that could be a vector specifying this, right? So in R3, you can write this as your vector. So that is how you can answer part B of C3. I hope that helps you to answer these questions, but if it's difficult for you to answer these, then I think you need to review these concepts, okay? Thank you.